everyone, welcome to our virtual class. This is Sir Reyes guiding you for our lesson for today. In our daily life, there are situations that can and cannot happen at the same time. Can you give me these examples? While driving your car, you cannot go to the left or to the right at the same time. You can scratch your nose and sit down at the same time. You cannot walk and run at the same time. In some manner, some of you here are studying their lessons, but at the same time, they're having their snacks. Am I right? Do you still have some situations that could happen or cannot happen at the same time? If so, you can write them down to your notes. But before we proceed with our discussion, do you still remember how to calculate simple probability? Let me test your understanding first with these examples.
And here is our problem. A jar contains 8 yellow candies, 5 red candies, 6 green candies, 4 blue candies, and 7 purple candies. If a candy is picked at random from the jar, what is the probability that a candy picked is yellow candy, blue candy, or purple candy? To get the probability of simple events, we have to use this formula of simple probability. For our problem, we have to get first the total number of candies, and that is our sample space. So we have 8 plus 5 plus 6 plus 4 plus 7 is equal to 30. Starting of our letter A, the number of ways to pick a yellow candy is actually 8. So therefore, the probability of getting a yellow candy is 8 over 30 or 4 over 15. Our second problem is to get the probability that a candy pick is a blue candy. The number of ways to get a blue candy is equal to 4. So therefore, the probability of getting a blue candy is 4 over 30, or that is 2 over 15. For our third problem, what is the probability that a candy pick is a purple candy? The number of ways to pick a purple candy is equal to 7. To get the probability of getting a purple candy, that is equal to 7 over 30.
That's a great job, everyone. At the end of our lesson, you should be able to demonstrate your understanding or apply the key concepts of the so-called mutually exclusive and not mutually exclusives.
So let me drive you with this activity number 1, occurring inspection. So given the following, could the two events A and B in the following situations happen at the same time? If yes, put a check in the box. If no, put a cross X. Get your paper and pen and try to answer the following. Number 1, you toss a coin. Event A, you get a head. Event B, you get a tail. And the answer is cross X. You cannot get a head and a tail at the same time. Let us have the second item. A card is drawn from a standard of 52 playing cards. Event A, a spade is drawn. Event B, a king is drawn. You may start now. And the answer is, it's a check. You can have a spade and a king at the same time through the use of king of spade. Let us go to number 3. One student is elected as SSG president. Event A, Eduardo is elected as SSG president. Event B, Amelia is elected as SSG president. What will be your answer? Timer starts now. Yes, the answer is a cross X because this cannot happen at the same time, because there will be conflict of authority if two persons act as one president. So let us come to number 4. Your wallet contains 3 20 peso bills and 5 100 peso bills. A single bill is picked. Event A, you get a 20 peso bill. Event B, you get a 100 peso bill. What will be your answer? Timer starts now. The answer is a cross because it was instructed that you will only get a single bill and you must not have a 20 on 100 peso bills at the same time. Let us have our number 5. You roll a 6-sided die. Event A, you get a 4. Event B, you get an even number. Could these events happen at the same time? Timer starts now. And the answer is, that's correct. These events can happen at the same time. 4 is an even number and can be one of the even numbers in a 6-sided die.
So how did you find our previous activity? Did you get a high score? The events in our previous activity can be either a mutually exclusive or not mutually exclusive events. So by definition, mutually exclusive events, these are the events that cannot occur at the same time. While not mutually exclusive events, and these are the events that can happen at the same time. I want you to go back with our previous lesson or activity. From the inquiry inspection, try to identify which of the events are mutually exclusive and not mutually exclusive. Since mutually exclusive events cannot happen together, what will be the probability that these events will happen together? Just to give you an idea, let us have this activity called something exclusive. This activity will help us derive a formula that will be very useful in answering our examples later on.
Let us focus on mutually exclusive events. Consider the following situations, then answer the questions that follow. Rolling a die. Event A is to get a 3. Event B is to get an even number. The probability that you get a 3 or the probability of A is a blank. From this given problem, as we all know, there are 6 possible outcomes in rolling a 6-sided die. These are 1, 2, 3, up to 6. So therefore, our sample space is equal to 6. To get the probability of an outcome 3, the number of ways that this outcome will occur is only 1. So therefore, the probability of getting 3 is 1 over 6. Our second problem is to find the probability that you get an even number. For this second item, getting an even number, you will have 3 possible ways. And these are 2, 4, and 6. So, the probability that you can get an even number is 3 over 6, or to simplify, 1 over 2. This time for letter C. We are asked to get the probability of getting a 3 or an even number. Since they have no possible way or outcome in common, there is no chance of happening together. We can use here the probability of the union of 2 events. And this tells us that we can only get the sum of both probabilities of the previous items. So, we have 1 over 6 plus 3 over 6 is equal to 4 over 6. Or, we could simplify that as 2 over 3.
As you notice, you are just adding the probability of each event because from the very start, the two events have no outcome in common. This tells us that the probability of these events that will happen together will be equal to 0. So, if two events A and B are mutually exclusive, then the probability that either A or B occurs is the sum of their probabilities. In symbol, we can write this as P, or probability of A or B, is equal to the probability of A plus the probability of B. We can also write this in other notation. We can have probability of A union B is equal to the probability of A plus the probability of B.
Let us have this situation about our problem a while ago. We are going to change the 3 into 4. The answer in letter A is also 1 over 6, since we only have one outcome of 4. For the second problem, we also have 3 over 6, since there are 3 ways to have an even numbers. For the third problem, getting a number 4 or an even number is a pair of not mutually exclusive events. Note, 4 is the one outcome that is common to events A and B. This is our solution a while ago, but we will remove this part. We will start adding 1 over 6 and 3 over 6. Then, to remove or subtract 1 over 6, that is belong to both A and B, which is the 4 common to the both. So therefore, 1 over 6 plus 3 over 6 minus 1 over 6 is equal to 3 over 6, and that is to be simplified into 1/2.
So if two events A and B are not mutually exclusive, then the probability of either A or B occurs is the sum of their probabilities decreased by the probability of both occurring. In symbol, the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. In other symbol, this will be the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B.
So let me test your understanding with the following problems. Again, get your pen and paper. Our first problem is a certain restaurant in Lingayen serves bukayo and other delicacies as dessert treat for their customers. They serve different types of bukayo like ordinary bukayo, bukarilyo, bukayo mani, and other delicacies. A restaurant has ready 16 ordinary bukayo, 10 bukarilyo, 14 bukayo mani, and 15 other delicacies. These are available in serve plate. Determine if the events below are mutually or not mutually exclusive, then find the probability that a customer will get ordinary bukayo or bukarilyo. You may pause this video and try to perform this kind of problem. To solve this problem, the sample space is 55. That's the total of all the different bukayo and other delicacies. We will only get the probability of an outcome for ordinary bukayo or bukarilyo. The number of ways to get ordinary bukayo is 16 and the number of ways to get bukarilyo is 10. So therefore, that will give us 16 over 55 plus 10 over 55 is equal to 26 over 55. Did you get the answer? Well done! Our second problem is a card is drawn from a standard deck of 52 cards. Solve for the probability of drawing a queen or red card. Determine whether the pair of events are mutually exclusive or not mutually exclusive. You may pause this video and check your answer later. To solve this problem, we will start with the standard deck of cards. It has 52 cards, so therefore the sample space is 52. Let us use Q as the event of the Queen of Cards, which are the Queen of Hearts, Queen of Diamond, Queen of Clubs, and Queen of Spades. This will give a probability of 4 over 52. Let us represent R being the event of red cards. Red cards have 26 cards. Those are the hearts and the diamonds in the deck of cards. So, the probability is 26 over 52. Note that there are common cards with these events. These are the Queen of Hearts and the Queen of Diamonds. So, the probability that both of these events will happen is 2 over 52. Therefore, the answer is you will have 4 over 52 plus 26 over 52 minus 2 over 52 equals 28 over 52, which will give us 7 over 13. Did you get the answer? That's a great job. Let us have our third problem. Suppose you will pick a letter from the English alphabet. What is the probability that it is either in the word agent or the word Mateo? Determine if the events describe mutually or not mutually exclusive. Pause and work for the solution and try to check your answer later. English alphabet has 26 letters. So, our sample space is 26. Let A be the letters in the word agent. This has 5 letters of outcomes. So, the probability is 5 over 26. Let M be the event of the letters in Mateo. So we have 6 letters. That will give a probability of 6 over 26. There are 3 common letters between agent and Mateo. These are A, E, and T. This tells us that the probability that both events will happen is 3 over 26. To finalize the answer, again, the events are not mutually exclusive. The probability of A union M is equal to 5 over 26 plus 6 over 26 minus 3 over 26 equals 8 over 26, or we could simplify that as 4 over 13. Did you get the answer? That's a great job.
Okay class, that ends our lesson for today. I hope you have learned a lot from our video lesson. Perform the learning task given to you by your subject teacher. And once again, this is Mr. Reyes, your math teacher, happy to serve.